Welcome, everyone. I have the pleasure to talk tonight about a big project that was initiated by the IEEE organization. Most of you might know IEEE as a standardization organization with over 420,000 engineers as members. And as part of their ethical engineering, ethically aligned design initiative, I had the pleasure of co-chairing for a couple of years the standard that you see on the slide that is now done, and it's called IEEE 7000, or since ISO adopted it also, it's called ISO 24748 7000. And it is a standard that shows how companies can basically conduct new forms of IT innovation, including AI innovation, that is value-based, that is ethical because it's value-based. And just as a very short background, because many of you on the call will have background here already on why do we speak about digital ethics at all? Why is such a standard important? Well, we have a couple of challenges. Some of them are dealing with a fear that was eloquently voiced by people like Elon Musk or Bill Gates and others who are afraid of a kind of AI supremacy. But that is certainly not the only challenge we have. But we also face quite vividly a lot of challenges with our current system, such as a willful degrading of humanity by software being designed to make us addictive, to undermine mental health, to create dependencies, to create hate and envy online, as well as e-personalities. And all of that is also linked and partly due to the fact that we have embraced in the IT industry, unfortunately, business models that erode our privacy and link people's attention to the business. And this kind of also IT innovations can not only be of technical nature, but when they are value-based, they must also look at the business model and the value proposition at the core of a business model. Now, these ethical issues observed are only symptoms of more fundamental technical, cultural, and economic problems that we face in engineering. One of them being software quality. We have started in the past 10 years with very agile and fast design thinking processes to develop software in a very rapid way and with less requirements engineering. Here, the last point on the slide says there is a developer mentality of problem fixing or solutionism. And in order to build more ethical and value-based systems, this is certainly a challenge to overcome. It is bound to problems of hardware quality because more and more hardware components are replaced by software components. Most importantly, and addressed in the IEEE 7000 standard, is another challenge, which is the complexity of software and system engineering these days, where a lot of the components that are embedded in a system, for example, AI capabilities, are coming from external service providers. And so often systems are basically a network of systems, and all of these need to be controlled and very well known in order to build a responsible design. Now, these challenges are meeting corporate cultures that are typically bound to very rational and efficient processes that need to deliver fast and at low cost. And corporate cultures sometimes tend to suffer from what here Brian Behrenbach, a former Siemens engineer, once described as follows. He wrote in an article, "We see a rush towards system delivery that can lead to problematic ethical behavior, such as the rushing of engineering jobs the difficulty to honor agreements, the lack of comprehensive and thorough evaluation of computer systems, a promotion of fictionware, and the tendency to sweep a lack of quality under the rug. This problem is not only something happening in large organizations, but it also very symptomatic in startups. Most of you have followed the discussions around Theranos and Elizabeth Holmes being on trial, but she's just the tip of an iceberg of many startups who basically are struggling with the challenges that I just outlined. Now, the regulators, both in the US and the European Union, have woken up on the problem. Most of the big organizations like Microsoft, IBM, Google, everyone has kind of understood that these problems are in the room. And the response has been largely by these big organizations, but also institutions like the OECD and the European Commission to come up with value principle lists and to say, here are a few values that we really want to respect in system design. You see here an overview of the most common value principles that are standing in the room. Privacy, that we have been discussing so much about, and security now are only part of a much larger list. Human agency and control, technical robustness, openness, transparency as a huge issue for AI development are all in these multiple lists, but the challenge is for us engineers, how do we actually go from these value principles to practice? How do we make sure that these list ideas, that these goals are actually ending up in the system design and in the system requirements? So we need a new IT innovation culture with a radically changed approach to IT development. This is my claim, and this was also the claim of the IEEE folks who met up and developed the 7000 standard. And just up front, there were a lot of people involved in this standard, so I'm just a spokesperson and somebody who's wrapping things up now as well and making them available for industry. There have been 35 active members in this work group for many years, and I think all in all about 150 people involved. 77 external judging experts in the IEEE network looked, finally judged in favor of the standard, balloted for it, said, yeah, it can go to practice. So what is inside? What can you expect in this 84 or so page cookbook of how to build ethical systems? Now, similar to standards like 15288, it is a process standard. It's a system development life cycle standard, which outlines concrete processes with activities and tasks that companies can run through to build a value-based ethical system. And you see these three core processes that are in the standard here on the slide. So the IEEE 7000 processes have three phases, which I'm going to present to you in detail in the coming 20 minutes. It starts out with context and concept exploration. That's the first phase. And then after understanding a system of interest, context and concept and con-ops, the second phase starts, which is value exploration. And after we have, through value exploration, understood what values need to be protected in a system and which ones could be fostered, we go to a third phase, which is ethically aligned design. This is also how IEEE called this going from principles to practice. You can basically read everything that I'm going to show you now in the textbook coming up that I've written. It's called Value-Based Engineering, and it's coming out in next March. Now, so what is inside? How does value-based engineering with 7000 start? The first phase, as I already said, is called concept and context exploration. And it looks at the context, it analyzes the system of interest, the system of system around it. It looks at stakeholder and integrated stakeholders, and it looks at the external partners and web services that are linked to a system of interest. So a couple of things. What do we do? What do we look at? What is the object of analysis here actually? It is a system with components. So it's a technical, concrete CONOP description that you might already have. Could be a prototype that you kind of sketch out with some block components, could be an existing system. And you're looking, see, I have here an example from a digital biometric tool like a teddy bear, biometric teddy bear. You see here several components, a voice system, you have voice controllers, you have gesture controllers. So you have things that are in the system of interest. And you have then external service partners linked up to this device with its components, like an AI service provider that provides speech, gesture recognition, all of those intelligent services that might come and serve the teddy bear's capabilities from outside. So IEEE 7000 is looking at a system of interest with its environment, system of systems, with its interconnecting services and the data flows between these. And this is a very technical starting point to say. But this system will be embedded in some kind of context. So in this first phase, we don't only look at component blocks, but we also look at where and how will this system be used. Yeah. So we are maybe going into concrete, let's say, the room where the teddy bear will be used in households, just as usability folks, HCI people do it today who study the user experience of the teddy bear. That's meant when the slide here says apprenticeship in the real world. So we actually try to really understand the context. And if there isn't a context yet, because such a service that we envision here doesn't exist, we may be using envisioning techniques with photos, videos, and other participatory design kind of methods that are known. So we have a system, we have where the system is being used and how we may envisioning its use in the future. And what we do is we also look at in detail at the partners. So this is something very important and especially important in the AI environment. We are recommending in the standard that when we link up, for example, to external services like a GPT language model, we say a responsible service provider should actually have control over the following partner-sourced services. You should have control over the quality of the data that is used in the AI system. You should have control over the selection processes feeding the AI, the algorithm design, the evolution of the AI's logic, and the best available techniques for a sufficient level of transparency of how the AI is learning and reaching conclusions. So when there is an interconnection with an external system of system provider, and that's an AI component, there are quite a lot of ideas in the standard of what we should actually know in order to be able to exercise a responsible partnership. So this is basically phase one. Phase one looks at the partners, the context, the state, and also something I didn't mention yet, and that's the stakeholders. So we will have, for instance, when we look at a biometric teddy bear, we will have direct stakeholders like the kids using the biometric device, the parents. We will have a household, we have friends, but we also have system designers, engineers, AI providers. So there is a whole bunch of stakeholders who somehow take an interest, are affected directly or indirectly by the system. And these are also identified in this first phase. And with their help, we now go to the second phase of value-based engineering with 7000. And in the second phase, the following question is answered that you see here on the slide. This is how does value-based engineering understand now corporate and social values that are associated with the system of interest and unveils these. So in the second phase, we already know the system of interest, we know its context, we know its stakeholders, we know what it looks like technically, and now we go into what we call a philosophical mode. And in the philosophical mode, we try to understand the values associated with the system, we cluster them, we prioritize them, and we conceptualize them. And let me show you why this is so important, this value work, the second phase. Where do we stand right now when we do value work in companies? Very often. Let me give you an example from the car industry of what value work looks like today, still, without value-based engineering. So here is Alexander Osterwalder, who invented the business canvas. And in a public talk he recently gave on Tesla cars, he said, the value of a Tesla car is, I quote, the car, a powerful battery, a lot of space in the car, luxury image, fuel for free, upgrades, great design, power range, and safety. And what you see on that list is actually that there are hardly any values there. There's only one value, I think that's safety. And so what I want to show you by this example is that there is obviously very diffuse ideas of what values are, because now we go to the next slide. In truth, we have to think much more precisely about values. So a powerful battery, as Osterwalder outlines, is actually nothing more than a disposition, a precondition that allows for certain value qualities, like, for example, a powerful battery will allow for more flexibility, time savings, and range of the car. And these value qualities then cater to a higher value, which is mobility. So on the left side, you see this very practical, but also diffuse kind of talking about values. And on the right side, you see how we actually need to stringently and structured, in how we think in a more structured and complete way about values, which is we have value dispositions here, value qualities, and they cater to higher values, like mobility. Or another example here, upgrades. Upgrades are just value dispositions, preconditions for more reliability of the car, which again caters to the higher value of safety. And lots of space is something that leads to spaciousness, which again leads to the higher value of comfort. And it is this precise thinking about values that is a major differentiator in the 7000 standard, because we have developed a precise language of how to actually talk about values. You see this here on the slide, coming back to the teddy bear. The device itself is the value bearer. We as engineers can only work on the right value dispositions. And these dispositions we embed in the value bearer. The value bearer has or then embodies value dispositions. And this is where we as engineers then work. If we're doing a good job, then the upper part in this slide becomes effective, which is the teddy bear may bear then positive value qualities. These positive value qualities, like in the context of the teddy bear, it has the value dispositions of speech recognition, speech actuators, and all of that. And this makes that the teddy bear can bear a value quality like a human likeness, that it can talk, yeah? And this human likeness is actually actualizing, materializing a higher value that is really wanted here, and that is happiness or joy in interaction. So you see here these terms, value bearer, value disposition, value qualities, and these actualizing ideal core values. And this is not a value language that we just came up with, but we took it from philosophy, from the phenomenological tradition, from a work, very important work by Max Scheler, that you see quoted here on the right side, his material value ethics from the 1920s. So this is a very rigorous work, and it has led to this kind of ontology, if you want to, of values and the vocabulary we use. I give you a few more examples. We can also have wrong or absent value dispositions, such as a poor encryption of the data that the teddy bear transfers. As a result, the ideal core value of security is undermined because there is a negative value quality, which is called a lack of confidentiality. So there is a lack of confidentiality because the value disposition of poor encryption is in the system. Okay, so with this, it also becomes clear a little bit how we define values. Values are phenomena disclosing the degree of desirability of something or someone, giving meaning to and motivating the selection of available modes, means, and ends of action. This is how we define values in value-based engineering. What is important in the 7000 standard as well is that we embrace the importance of virtue ethics. So we would also question in the philosophical mode whether a system can actually undermine people's virtues. We have a lot of discussion right now that, for example, our social networks are breeding hate and envy. So here we are talking about virtues that are being undermined, yeah, or vices that are being developed through wrong system design. Here on the slide, if a teddy bear always gives only positive feedback to the kids, a negative value quality could develop over time, like inflatedness, which undermines the ideal core value of prudence. So we are having in the standard the question, and that we ask stakeholders to reflect on the following. What are the negative implications of the system for the character and or personality of direct and indirect stakeholders? That is, which virtue harms or vices could result if the system was implemented at scale? So this question is embedded in our philosophical mode, and it is one of three questions actually that are coming from moral philosophy, because we also ask with the utilitarian notion what human, social, economic or other values are affected, positively or negative, by this planned system of interest. Or duty ethically, what personal maxims or value priorities does the project team see affected by the service that the project team members believe are so important that they want to preserve them in society? So these three pillars, virtue ethics, utilitarianism, and duty ethics, are our formal ethical tools to help innovation projects to actually find, understand, and unveil the value, quality, and ideal core value effects that are implied by a system. And typically, when we are doing studies, case studies, when we work with companies, and we ask these three actually very simple questions, we come up with a value space of 40, 50, 60 values that could be harmed or that could be fostered. And what we are doing then in the standard is we structure and cluster this value space into core values, I mentioned them, that are surrounded by their positive and negative value qualities. And we have these value clusters that are then being prioritized for later system development. And the prioritization criteria that we have in the standard are that the innovation team, the project team, together with top management and stakeholders, and potentially also critical stakeholders, should reflect on the business mission, on existing CSR principles, on laws, on human rights principles, on environmental sustainability issues, and other criteria that help the company to prioritize and rank the most important core values and value qualities that should be respected in system design later on. Once this is done, we can go to the last and third phase of value-based engineering, where we then translate these value principles into practice. and define system requirements. So how is that being done? What we're doing here is the following. Imagine you have identified the value of privacy as an important value that you want to respect in the system. Here on the slide, you see from a case study that we did with UNICEF with the YOMA platform, that there are several value qualities now that need to be respected in the system design in order to get a private system in the end. One of them is informed consent, for instance, but also transparency, data security, data portability. All these are value qualities that need to be in place and engineered, respected for privacy to unfold. And with this value cluster and these value qualities, we now define something called EVRS, ethical value requirements. That's a completely new construct in system engineering. And it only exists and was developed in the 7000 standard, ethical value requirements. And these are derived from the value qualities and clusters as a kind of bridge, as a kind of intermediate requirements concept that is the outset and starting point for system requirements. Let me give you one example. If I have a core value like privacy, and I have a value quality like informed consent that needs to be in place for privacy, then the ethical value requirement, the EVR, would look something like what you see here on the slide. So it would say, for an informed consent, there must be a meaningfully and as the company must meaningfully and comprehensively describe the company's personal data processing activities. The company must truly and voluntarily obtain users' processing consent. It must offer users easily accessible options to provide or decline consent. It must avoid user consent to something they don't understand. So what you see here, what the EVRs are doing, are actually very clearly defined, precise criteria for putting a value quality in place. And these criteria are then translated in the next step with a risk-based approach into concrete system requirements. So I'm not sure whether you can read this really well. I'm sending around the slides later. You see here, again, just look at the first column. Privacy is actualized through the value quality of informed consent. This means that there must be meaningfully and comprehensively description of personal data processing. And then the EVR thread would ask what could actually happen that there is no meaningful or comprehensive description of data processing activities. So the EVR thread would be formulated. And then for each one of these threads, we are setting controls, which are the system requirements. So, and the example here on the slide is that the privacy policy is not meaningful, disguising information that is really relevant for the user from a privacy perspective. And the control is offer a complete and honest overview of personal data sharing and processing activities. So you see that the threat control logic is used to address EVRs, which are directly related to value qualities and core values that you want to create in a system. And all of this logic from the ethical, starting from the ethical analysis with the virtue ethics, utilitarian ethics, and so on, we go with various forms all down through the system requirements. And I think almost with this, I'm done. I have a little case study that I don't think I have the time to show you. But what I can share still is that in the various case studies that we did, both with real companies and with fictitious cases, is that if we use moral philosophy and apply it to a system of interest. We applied it not only to the smart teddy bear, but also to a telemedicine platform, to a bike courier platform. We will now work with BMW, we work with UNICEF, but the 3 case studies where we really witnessed quantitatively the effects of using 7000, we see that by using moral philosophy for value elicitation, we see an explosion of stakeholders recognizing positive and negative value potentials in comparison to our current product road mapping activities. So you see here on the slide, current product road mapping. When you develop a teddy bear telemedicine platform or bike courier platform, as was always done, and you compare it with our approach, then you see that the number of value potentials, positive and negative, seen are much, much higher, going, for example, from 4 values seen in product road mapping to 19, or from 4 for a teddy bear to 16. And we also see an explosion of product ideas, what could be done to make the system better. And we also see that on average, all stakeholders involved see around 10 things that could go wrong, whilst in product road mapping, they hardly see anything. And also we see that investment decisions are getting much wiser when you use value-based engineering. On this slide here, we are going again back to the toy, to the digital toy. We asked our participants in the case study at the beginning whether they would be investing in the digital teddy bear, and many of them are very friendly towards technology, and they said 66% yes, let's invest in the teddy bear, in the biometrics. And then they did the ethical analysis, and we asked them again, would you invest? And suddenly they see all of those things that can go wrong with the moral philosophy, and 66% say, no, we don't invest, we shouldn't do it. But then we tell them, why don't you think with value-based engineering about EVRS and system requirements, you could cater the product to actually avoid harms and foster positive values. So imagine a company would do that. Would you then invest in the digital toy? And then 91% say yes, if the system is hence adopted and improved, then we would also be very happy to see it being built. And with this, I'm at the end. Where do we go from here? We have released the 7000 standard last year in the fall. This year in the fall, it has become an ISO standard. IEEE is about to put out certification and is educating also with my help people who are becoming value leads and who can be assessors for 7000. And also in my own work at the university, we continue publishing and develop the literature around this approach, including an online course that I'm happy to give you access to. Thank you very much.